The universe is getting bigger. Not just expanding, but accelerating as it expands. Most cosmologists say this is because of a mysterious thing called dark energy. But what if there's another way to look at it? What if the universe is actually rebounding as space itself relaxes from the extreme conditions of the Big Bang? Today, I want to put two ideas side by side: the standard dark energy story versus a rebounding universe where space flattens and accelerates as matter spreads out. Let's start with what almost everyone agrees on. The universe is expanding. Galaxies are moving away from each other, and the more distant they are, the faster they recede. In the late 1990s, by studying distant exploding stars called Type 1a supernovae, astronomers found something surprising. The expansion of the universe isn't slowing down. It's actually speeding up. That's strange because gravity is attractive. You'd expect expansion to gradually slow, like a ball thrown upward. But that's not what the universe is doing. Before we go further, quick clarification. Dark matter is the stuff that pulls with gravity. It helps hold galaxies together and shapes the large-scale structure of the universe. Dark energy is different. Dark energy is what we use to explain the accelerating expansion of space itself. It acts like a kind of repulsive gravity on the largest scales. In this video, we're focused on dark energy, not dark matter. In the standard cosmological model, called lambda CDM, the story goes like this. The universe began in a hot, dense state, the Big Bang. It expanded and cooled. At some point, a mysterious component, dark energy, started to dominate the energy of the cosmos. Because dark energy has negative pressure, it causes the expansion of the universe to accelerate. In this picture, only about 5% of the universe is normal matter: stars, planets, you and me. Roughly 27% is dark matter, and about 68% is dark energy. This model fits a lot of data very well, but we still don't know what dark energy actually is. So here's the big question. Do we have to add a mysterious new form of energy to explain acceleration? Or could the acceleration be a natural consequence of something else? Like the way space-time itself responds after being extremely distorted at the Big Bang. This is where the idea of a rebounding universe comes in. Let's rewind to the very beginning. At the Big Bang, matter and energy were packed into an incredibly tiny, incredibly dense region. In general relativity, mass and energy curve spacetime. So in that initial state, spacetime is extremely distorted. Now imagine that as the universe begins to expand and matter spreads out, the fabric of space is no longer under the same intense compression. Instead, spacetime begins to relax. It starts to rebound or flatten from that extreme initial curvature. In this picture, the expansion of the universe isn't driven by a separate dark energy fluid. It's driven by the geometry itself trying to recover from an overcompressed, highly curved beginning. Here's a simple analogy. Imagine a stretchy rubber sheet. You press your finger into it, making a deep dimple. That's like all the mass and energy piled into one tiny region. Now you suddenly remove your finger and spread that mass out. The sheet doesn't just go flat. It springs back, overshoots, and ripples. In a similar way, you can imagine space-time relaxing from its initial extreme curvature. As matter disperses, the rebound of space could naturally lead to a phase where expansion actually accelerates. You might be wondering, if space is rebounding that fast, does this break the speed of light? Relativity forbids objects from moving through space faster than light, but space itself can expand faster than light. This already appears in cosmology. During inflation, space expanded faster than light. Even today, very distant galaxies can recede from us faster than light because the space between us and them is expanding. So in the rebound idea, galaxies aren't rocketing through space superluminally. It's the metric, the size of space, that changes quickly. Let's put the two scenarios side by side. Scenario A, dark energy. We add a new component to the universe, a form of energy with negative pressure, It explains the observed acceleration very well and matches a lot of data, but its true nature is still a mystery. Scenario B, rebounding space. We don't introduce a new kind of energy. Instead, we treat acceleration as a natural relaxation of spacetime from a highly curved, compressed beginning. As matter spreads out, the rebound of space can speed up expansion. Right now, the rebound idea is conceptual. To compete with the standard model, it would need precise equations and detailed predictions, and it would have to pass the same observational tests. So why talk about ideas like this at all? Because cosmology is still young. We've only known about the accelerating expansion for a few decades. We're trying to explain the entire universe using a mix of observation, math, and some carefully guided imagination. The dark energy model might be exactly right, or it might be a very good approximation to something deeper about the geometry of space and time. The rebounding universe idea asks a different question. Is acceleration telling us about a new kind of energy? Or about how space-time itself behaves after being pushed to an extreme? In the end, cosmology isn't just about equations. It's also about the stories we tell to make sense of those equations. One story says, the universe is dominated by an invisible dark energy that pushes space apart. Another says, the universe is still rebounding from its own birth, space flattening and accelerating as matter drifts apart. Which one feels more compelling to you? And more importantly, what observations could help us decide? Let me know what you think in the comments. Are you team dark energy, team rebound, or I need more data?